My name is Lauren Hawkins, and I am here to help you learn a little bit about expected value, which is a concept you can see in any statistics or probability course. This is a Google Slides presentation, so if you would like your own copy of this to put in your own Google Drive, feel free to use the presentation link down there below that is shortened. Please be aware it is case sensitive, so the E and the V both need to be capitalized. Good thing about that presentation link is that it is actually the title of what we'll be discussing, which is expected value. So we're going to look at how to calculate and interpret expected value in a statistics course. If you have a calculator, you will need it. The screenshots that I show in the video are going to be with the TI-84 calculator. So if you have something similar or comparable, the screenshots will make sense. If you don't have one, don't worry. Hopefully you'll have some kind of calculator to help you. So I want you to pause the video really quick here to try to answer these quick thoughts on your own before continuing on, because these are the main ideas that we're going to be using, and they're going to help you intuitively understand the formula that we will be working with. Okay, so looking at tests, quizzes, and homework, each are weighted a little differently looking at the current grade. Hopefully that was the calculation you used. It should have been 81.4 for the grade in the class. So notice you take a certain percentage of each grade. So it kind of helps you understand how the grades are worth, because again, not all three categories are equal. Obviously, tests are going to be worth more than homework, and notice the calculation takes that into an account. When looking at a fair coin, notice you have a 50% chance of getting heads. If you toss the coin 8 times, how many can you expect to get? Well, if I toss it 8 times and I've got a 50-50 shot, hopefully I expect to get about 4 heads. And that can be a give or take number because I might not get exactly that, but I should get that on average, which is the exact idea behind expected value. So the formula on expected value is when you have each individual idea, so whether that's an outcome, a grade, something along those lines, times the probability that that actually occurs. So in statistics, you tend to shorten that formula using a sigma notation, which is what that sum is. It is a Greek letter, but it basically means multiply the individual x's by their individual probability and add them up. Math people tend to be very lazy. We like some shorthand. But if it helps, think of it just like a weighted average. That's the easiest way to think of expected value. So again, please pause the video and try to answer this question on your own before continuing. All right, welcome back. Hopefully you got on the first one, you expect around $20 to pay out per policyholder. So that means every person that signs up, I'm on average going to have to pay out $20 for them. So notice if you're insuring 200 clients, you're interested in the profit. Well, I'm going to have each client pay $100, and profit is always going to be the revenue that I make minus the expenses. Well, the revenue I'm making is the $100 per client. The expenses that I'm having to give is the payout, that $20 again for each client. So hopefully on that you did total revenue and expenses to give you $16,000. Not too bad. So, calculator steps. If you have a TI-84, go ahead and click on the Stat button, and you're going to choose option number 1, which is Edit. Should give you a list, so you're going to put in L1 the money from the insurance and then the chances it occurs. Then you're still going to hit the Stat button again. You're just going to arrow over to you get one variable statistics. So on this screen, it's going to be a little bit different because the list that you're going to need to use is L1 because that's the company payout. L2 is the frequency or the chances that it actually occurs, which is what we put in L2. Then you can hit calculate and you'll get exactly what you need. So notice it's still $20 on average. Pretty nice. And again, X bar is a notation you probably have seen in a statistics class. It just means average, but that's what expected value is. All right, so standard deviation. So again, if you've been in any stats class, you've probably seen this. If it helps, check out my previous video on standard deviation if you don't know what it is. But I explain it a little bit at the bottom because it's really how much you expect your expected value to vary. So you still find how far away each point is from what you expect. And again, you square those distances to make them positive. And again, times the probability that they actually occur. And again, math people like their shorthanded notation. So that I, again, is the individual. You could see X bar in the blue instead, but I just put EXP just to keep it a little bit friendlier. And it's also on that one variance stat screen. Notice standard deviation is sigma, variance is squared. So you do need to keep that in mind when making that calculation. But on the calculator, it will give it to you. So I can expect to pay out $20 per policyholder, give or take $386.78. All right, I'd like you to pause this video. Please try to do this one on your own and hit play when you're ready to see the answer. All right, I used L1 and L2, and I also used list 1, list 2 to help me. So hopefully you got around, I can expect 1.7 visits to the dentist on average a year, give or take 0.994 visits. Not too bad. All right, so on this one, this is a game of roulette. If you've not played, you basically bet on an outcome and then you win certain money. So the biggest thing you need to know about a roulette is you have 38 pieces. You have 16 of them are red, 16 are black, and 2 are green. So on that board, you can see a chip has been in place. And notice this was called a corner bet because you're covering the corners of 4 numbers. This is actually 8-to-1 odds. Basically, for every dollar, your payout is $8. So let's go ahead and give this a quick try. So this is the roulette wheel. So notice the chances of you landing on red. Well, you have 18 out of 38 that are red. But again, you only make $1 if you're betting on a color because it's a 1-to-1 odds. So if you win, you get your dollar. But notice you could also lose the money. So notice you have an 18 out of 38 chance of getting the $1, but your odds of losing that dollar. Hopefully in your calculator, you've lost about 5 cents. Now 25 is an interesting number because notice to bet on a single number, it's 35-to-1 odds, which sounds pretty awesome. But again, that's one number out of 38. And again, there is the chance that I lose that dollar. So notice $35, I have a 1 out of 8 chance of that happening. And again, just like expected value, I have to include all the outcomes. I could also lose that dollar, but I have a 37 out of 38 chances of getting that. Here's the interesting part. If you do calculate that, guess what? You've also lost 5 cents. A corner bet is what we saw on the previous slide, where I get to pick 4 different numbers. And again, 8-to-1 odds, so I win $8. Ooh, and I lose. But here's the very interesting thing. Oh, would you look at that? And again, these numbers are averages. So over a period of time, basically every dollar I bet, on average, I'm going to lose 5 cents. Yes, it's possible in gambling to come out on top, but that's really, really tricky because you think you're due to win money. That's not how this works. This is just an average. If you keep playing forever and ever and ever, you're going to lose. But kind of interesting to see how the casinos work. All right, again, please pause this video because this one is a little different. Notice there is a picture given, but there is no table like on all the previous ones. So please try to do this one on your own. Hit play when you're ready to see the answer. All right, expected point total. So notice you have 3 outcomes. I can land on a 1, I can land on a 2, or I could land on a 3. Notice the outcomes of each one of those. There's 3 out of 6 chance I'm going to get a 1, a 2 out of 6 chance I'm going to land on a 2, and a 1 out of 6 chance I'm going to land on a 3, hopefully giving me a 5 divided by 3. So again, that's the expected point total for any one spin. If you spin it 3 times, well, if one spin is 5/3 and I'm going to do that 3 more times, hopefully you found a total of 5 points in 3 spins. Again, on average, so be very, very careful. All right, in this first example, so this is good AP statistics or just statistics probability practice because there are going to be multiple choice answers. But I want you to try to do this one. Notice it's the same wheel. I'm just taking it up a notch. Please hit pause. I've set up the table. Try to understand why I set this up. Hit play when you're ready to see the answer. All right, so notice you only have certain outcomes. You either get less than 6 points, you get between 6 and 8 points, or you earn 9. Notice you have bet $1 to play, so here's the problem. Notice if you land on less than 6, you win nothing, so you have negative $1. If you land between 6 and 8, you win $1.50, but you bet $1. So really, you only won 50 cents. Same thing with 9 points. You won $5, but again, you put $1 in, so really you're winning $4. Here's the nice thing. The only way that you can earn 9 points is if you get 3 threes in a row, which means you have, and notice those threes are a 1 out of 6 chance. So you have to get a 1 out of 6 chance 3 times in a row. So 1 out of 6 cubed, which gives you 1 out of 216. The other two options are a little harder because 6 to 8 points, you have a lot of outcomes you have to consider. Here's the good news about less than 6 points. Think about how that would be possible. Well, if you're spinning 3 times, the only way that you're going to get less than 6 points is if at least one of those spins is a 1. So if that's going to happen, in statistics, this is called the complement rule. For us, it's a lot easier to figure out, well, what are the chances I don't land on a 1 at all? And then I can take the complement of that to get 1 or more. If you don't quite understand that, please watch one of my previous videos to help you see that, because that is such a foundational thing in a statistics course. So on here, I have 1 minus the chances I get no 1s on 3 spins in a row. And then again, the good news is I have 2 of my outcomes. Well, the whole thing has to equal 100%. So I'm just going to take 1 minus the other 2 answers, which gives me 13 out of 108. All right, now I get to find the expected amount worth. Notice I do have the answer choices here, so go ahead and pause the video and try to find the expected amount before hitting play. All right, hopefully you got answer choice A, which is you're losing 80 cents. So again, probably not an amazing game that you want to play. Again, feel free to pause the video to jot this down or really look at how I did that calculation. If you did it in the calculator, this is what's really nice about the TI-84s, is you can do the calculations in the list. So you don't actually have to put them on the side and then put them in the calculator. You can perform them in the list and the calculator will understand. Notice the answer is off by a little bit because it says 92 cents and not 80 cents. The calculator will not round, so that's why it's a little higher. So if you did it on the side, your answer is going to be around 80 cents, or negative 80 cents, just because of the rounding. So usually you can pick the answer that's closest. All right, again, please hit pause to try this one. All right, this one's a little bit interesting because, again, you have money that's being bet. Notice you do have 12 face cards, different money amount for each one. And again, I'm thinking about my net profit. So even though I'm paying $2, well, if I get no face cards, I lost my money, which is why you see the -2. All right, so for us, let's figure out the chances that I'm going to get some face cards. Here's the problem. It doesn't mention anything about keeping the card or putting it back. So you do need to be very careful how you handle that probability, which is why on the very first one, you have 12 out of 52 face cards, but the next one you get, now you only have 11 chances out of 51. And again, I keep the card, so now I only have 10 face cards left. So that's where that probability comes from. You can use this exact same idea to do 0. So notice you have 40 out of 52 are no face cards, and then 1 minus that and 1 minus that. The weird thing about getting 1 face card is that face card can either be the very first card you draw, the second card you draw, or the third card that you draw. So even though I have this calculation, I get a face card, 12 out of 52, but then I don't get a face card and I don't get a face card. That can happen in 3 different ways. That's why I'm multiplying by 3. And then to get 2 face cards, I did 1 minus the others. And again, you can put those in a calculator. You're going to get answer choice C. And again, you can do these calculations in the calculator. Notice I did that right here. So in list 2, I can actually put that really ugly fraction and it will understand. If you aren't familiar on how to make fractions in a TI-84 calculator, this is on the newer operating system. You can hit alpha, y equals, and you can hit number 1. That'll give you the fraction option. And again, finding the calculations is always stat, option 1 to make sure that you edit, and then you choose 1 variable statistics. All right, again, please pause the video, try to do this one on your own. All right, so here's the nice thing. You have 3 possible outcomes. No rain, it rains on one of the days, it rains on both the days. So the good news is if it doesn't rain at all, so no rain and no rain, well, there's a 70% chance that it will rain, which means there's a 70% chance it doesn't, and a 50% chance it doesn't rain on the other day. Notice it says if it rains either day, she'll have to pay for touch-ups. If it rains both days, she gets her hair. Well, the nice thing is if it rains and it rains, You can do 0.3 times 0.5, and again, it rains on either day is 1 minus those other two. Notice you have the amount that will happen, so multiply it on out. Notice I put $0 on 35. That's because guess what? If it doesn't rain, she doesn't have to pay to get her hair touched up. She only pays on the days that it rains. So really, I struck through the last one because you don't really need it, because you're just interested in whether you're paying or not. So, answer choice E, $16.50 is how much she can expect to spend on touching up her hair this fall. Well, I'd like to thank you for joining me in this video about expected value. Please subscribe to my channel so you can watch more statistics and probability help. Feel free to comment if you have any questions or share this video to anyone that needs it. Thanks for watching. Have a great day.